Hello and welcome to Section 5, For Loops in Theano and Recurrent Neural Networks. So far, we've been training models where independent inputs require a single independent output. For example, in image classification, each image is fairly independent of each other. In the last section, we even saw how to use pre-trained models to solve problems like those. But what happens when the input is something like a text, where each word is part of a context? For problems like those, we have to use neural networks that have an internal state, such as recurrent neural networks. In this section, we are going to talk about Theano for loops, the scan module, recurrent layers, recurrent versus convolutional, and finally, recurrent neural networks, training a sentiment analysis model for text. Let's start with Theano for loops, the scan module. In this video, we are going to write a simple Fibonacci sequence generator using for loops in pure Python, and we will see its equivalent in Theano. Here we are in our IPython notebook to do some coding. To write our simple Fibonacci sequence, we start defining a few values. First, the length of the sequence. This is the number of steps in the for loop. We choose 10 here. Let's write our for loop in a modular way. We start by defining our step function, which is how the states of our for loop will be modified. Here the rule is simple. Null state 1 is just the sum of the previous two states, and null state 2 is the previous state 1. The for loop itself, it's pretty straightforward. It just calls the step function several times and append the last value of state 1. Here's our sequence. Now let us see how to do that with Theano. To write a for loop in Theano, we have to use the scan module, and you can import it from Theano just like tensor and function that we've been using in our other examples. Here's some documentation about it. Scan takes a mandatory parameter underscore step, which is the step function, just like the one we wrote above that receives input sequences, and node states and returns new states. I also wrote here some analogies to pure Python to help us understand what the other parameters of scan do. So the second parameter is called sequences, and they are inputs that we can iterate through. For the Fibonacci sequence that we are writing, we iterate through a number of fixed steps. So instead of creating a range iterator, we can just pass the parameter n underscore steps, and Theano does the rest for us. Output info is a list with values of the initial states. That list should be of the same length as the number of values returned by step. We will not use non-sequences here, but it can contain parameters that will be kept fixed in the entire loop. Truncate gradient is not often used, but they control how long back in the for loop you want your gradients to go when you're doing backpropagation through time, which is the equivalent of backpropagation for recurrent neural networks. Okay, now to the Theano loop itself. We start, as always, defining our placeholders. Here, two scalars, h1 and h2, that are the initial states for the for loop. The step function is exactly the same as in our pure Python implementation. Here's how to call scan. It will return two lists, outputs and updates. This outputs list has the actual generated sequences, and the updates contain updates to be used inside the compile function. This is for the case we use a random number generated inside the loop, and Theano needs to update these random values. In our example, we can just ignore this updates list. The input parameters are sequences, in our case an empty list, which forces us to pass n steps as input. Remember, here length is just n, so Theano knows how long the for loop has to be. Outputs info, or initial states, are our placeholders that we defined above. Finally, we call function to compile the scan outputs, passing the placeholders as input. Now, we call the compiled function f, passing 0 and 1 as the two initial states, the default initial states for Fibonacci sequences. F returns two lists, because can return a list for each value that is in the output of step. So here we have two values. This is why f also compiled two values. This first list is exactly what we were waiting for. A sequence of Fibonacci numbers generated just like the pure Python equivalent. Obviously, we could force Theano to compile just the first list by modifying the output of the compile function like this. In this video, we learned how to format Python for loops in a way that can be easily translated and implemented with Theano. In the next video, we will use these for loops to define recurrent layers for neural networks.